Hi, my name is Matthias and I'm founder and CEO of Tensier. We're new to the Suricata community and we're excited to become part of it. At Tensier, our mission is to empower security analysts with efficient tools for hunting. And to this end, we've developed an open source platform called VAST. In this talk, I'm going to show you how it can be used to streamline pivoting across different types of data. So VAST stands for visibility across space and time, and the tool takes various network telemetry data, and specifically PCAPs, net flows, Argus data, if you still know that tool, MRT, but also the tools of the trade on intrusion detection systems. And if that's not enough, there's also generic adapters where you can feed in any type of data. And the tool itself indexes and archives the data, and you can get various formats, the data. You can get it in different types out, the same way you put it in. And that's actually, and on top of that, you can efficiently connect your downstream analysis, whatever you want. If you have Python, R, Spark, what we're trying to do is with VAST is create really a big plumbing for data-intensive post-processing. The idea is not to create yet another Elastic with all vertical stacking on top of that, but really just a minimalistic but very high performance engine for security telemetry. And on top of that, we're building also integrations. And right now I'm in the process of writing a Sigma backend, so we're trying to really integrate here, what I'm trying to say, with the most important things. And just to give you a very basic idea how it feels to currently work with the tool, it's a command line tool at the moment. I want to switch to a quick demo. Let's see if that works. Okay. So I've preloaded some data. In this one, I'm still going to start the process, the server process, and in the bottom panel, I have the client process. So it's a command line tool. You have various subcommands. It behaves like Git, essentially. And just to quickly show you maybe how you want to start off something. Damn it, it shows everything already. My shell is a bit smarter than I want it to be. Okay, let's try to hide that. Here, let's say I want to render some data in the JSON format, and a very common way to start is maybe just show me the Suricata alerts. And here I'm limiting the output to 10 events. I've done something wrong. I'm missing a double quote, I think. So here I get the events back, but I can go through them. These are just the first 10 alerts. And roughly, this is actually preloaded with around 3 million events right now. I can actually render that in CSV as well, just to show you the flexibility. That's the exact same data. It's an internal data model that allows you to render it in arbitrary form. You can even render it as zglog if you want to. That's the wrong conference for this. And you can also just dump the data. And there's various ways. But that's just a very quick intro. And I want to go back to the slides now. Internally, it has quite a flexible data model. IP addresses, ports, so all the domain-specific types, but also more richer types like containers or compound types. And the query language is a mix of awk and BPF. And here are some examples. And just want to pick out one that would essentially limit the search to all Suricata alerts, and would then combine that with another predicate, essentially, where the source address, the source network is not in a specific subnet or where anything that contains a string eval. And that's, the language itself supports basically Boolean algebra and or not and sub-expressions. And the predicates are also what you would expect. There's a left-hand side, an operator, and a right-hand side. And on the left-hand side, you don't have to know the schema in advance. You can also just express the search in terms of types. And because it's a rich type model, that's really useful. And we're also in the process of supporting elastic common schema so that if you know exactly what you're looking for, then you can do it independent of the format, and it retains the original format too. So it's really meant to be simplistic, but yet powerful. And how that helps is especially when you have multiple heterogeneous types of data in it in the same data model. And then, because traditionally you would have your, say, your log store with Suricata logs, and then your PCAPs from your bulk packet recorder. And what we want to build with VAST is really the ability to have a unified store that does not require this dichotomy. Usually there are very different requirements for a log store versus a raw bulk packet recorder. And when you have to kind of go from one lead in the log to the PCAP, it's usually manual correlation that you have to do. It requires also that your PCAP store has some sort of way of cross-referencing it, and with the community ID, that's today pretty possible. And we wanted to unify this, and the key is really that we use the notion of a schema, and we leverage the type system rather than the unstructured data. And you can technically pivot between all the different tools, and each of these tools has its own log types. And for Suricata, there's the flow, the HTTP, the alert, the DNS, the DHCP. And within the Suricata logs, it's a strongly connected graph. You have the flow ID, you can go between every other entry. Nowadays, there's also the community ID, which allows to pivot to other formats, not just intra-Suricata, but also, say, to the PCAP. Or actually, you can also go to Zeek with the same way. Zeek has also support for community ID, thanks to my colleague Christian Kreibich, who pushed that effort very forward. And that makes it really powerful to, say, have these multi-hop pivots where you have within a tool, you have your own way of pivoting, but then across tools, you need one common denominator, which is often the community ID. And then you can, say, here jump from an Suricata alert to the corresponding connection in Zeek, and then to the file UID. And we want to hide this kind of hopping relationship in the tool. We just want the user to say, hey, give me all the file information based off this alert. So at the moment, we have only support for one-hop pivoting, but eventually it will not be limited to that. And how that actually shows and how you can use it in practice, I'd like to demo a bit more concretely right now. So let's say I want just 10 alerts. Oh, thank you. These were the 10 alerts that I was showing earlier. Some, ET policy, PE, download. And I'd like to hone in a little bit more on the signature ID. So I'm going to just add that specific signature ID. And then I'm still getting the data, just a bit smaller subset. And now what I want to do is, hey, give me all the PCAP for these matching alerts. So then I'm using the pivot command. I'm going to say vast pivot to PCAP packet, that's the type. And actually what I'm getting back is the TCP dump file for it. It's just, that's all the raw traffic. It's all in one system. And it's quite easy to access. And that's really useful. And in fact, we can we can even pivot to different types. Now we can pivot to the Zeek connection log based off this alert. I don't even know what the edge in that type graph is called. I just want to know, hey, here's my alert, and I want to go there. And what I'm doing now is just showing you that plain data, pivoting to the Zeek con log, and there are the connection logs for Zeek. So that can be quite powerful because you can really focus on the result of what you want to do. And yeah, you can imagine, like, you can pipe this now into another run of Suricata and run the file extraction on it, and you get the files, and you're ready to go. So I hope that gives you an idea of what we want to do with this pivoting. And that's flexible. And I want to go back a little bit to VAST to give you an idea of where it's currently at. For those of you who have a running Elastic or Splunk, the idea is not to rip it out, but just to give you some numbers, how it performs, really. We have run some experiments on our local development computers, which are iMacs, and used the current VAST master and compared it against to Elastic 7.1. And that was the file beat import without logstash and the ML module disabled. And we used roughly a gigabyte of data on the input side. We generated Suricata and Zeek logs from that trace, and inflated that trace artificially to roughly have a 1 gigabyte data set. And we haven't really done much, but we actually see still already a 7x increase in the ingestion throughput. That's roughly around, that's what we observed. But keeping the storage utilization is roughly the same. And we have not done any optimization at all. We've just coded it down and haven't looked at it yet in detail. And there's a lot of room for improvement. But that gave us confidence that we're on the right path. And for those who want really a simple single static binary to replace a rather complicated setup, we hope that VAST is proving an interesting alternative, especially because it's also open source and a permissive license, a BSD license actually. And that's something we want to establish more and more. And the rich data model, the query language, and the first class for support for Suricata hopefully makes it also attractive for you. And internally, the system is implemented in cutting-edge C++ 20. When we started the project, Rust wasn't very mature yet, but another advantage is by choosing the C++ ecosystem is that we can rely on a lot of existing code, and it has a very mature standard library. And also we have worked extensively with an actor model implementation. So the actor model is pioneered by Erlang, and WhatsApp is also written in that. It's a very powerful way to express concurrency and distribution independent of threads. Essentially, actors are spawned all in parallel, and within an actor, control flow is sequential, and you have hundreds and thousands of actors, and they map to the number of threads. So in the code base, there's no single block, but it's all expressed in terms of actors when concurrency is needed. And that also can scale just very natural to clusters, so that the cluster deployment is something we are looking at next. And underneath, I kind of want to go back a little bit to the schema talk from earlier. So what we have right now is our own little schema language here, but it's effectively what Sasha showed us earlier. We went manually through the output and tried to infer the types. It's cumbersome, and we're really looking forward to use that auto-generated JSON schema. The difference is that we have a bit more of a distinction between types and strings and other identifiers. So addresses are supported first class. So we're really looking forward to figure out how to get that extra value context from the rules. And something that's that could also be interesting is the ability to use these type-based operators such as top K prefix search. If I'm looking again through the first alerts here, and I see the destination IP is, I want to filter out based on a specific IP address or a subnet that was dest IP, and I can say not in that part, and yeah, still got 11. Can expand that to a /16 or so. That's actually quite a large address space. And at some point, I will. I can narrow down the results in this, but with this exclusion, that's what I'm trying to get at. There's a type-specific operation on IP addresses, and on the left-hand side, there must be an IP address type for this query to work, and on the right-hand side, there's you can specify either an address and then use the equality operator, or you can use a subset query with the in operator or the not in. So the entire query language is typed, and you can't usually get an error message back if you make a failure, but it's a bit different than the purely based JSON style processing. For those who are used to awk and to BPF filters, it would probably come very natural. And right now, the backend still owns the data, but what we want to get at is that VAST is just pointing to it so that you can eventually are not locked into your Elastic or Splunk data silo, and you can store it in your HDFS, NFS, or whatever, S3 bucket, and then still materialize it with VAST and efficiently shove it to your tools for downstream analysis. That's the goal, and it's quite a while. It'll take us a while to get there, but we're just starting with this. We're a young startup based out of Hamburg, and we really would be excited to take on new users and really learn your use cases and see where we can connect. So please talk to me if this is exciting to you, if you could see use for it. And thanks for your attention.
Yes, I've got a question. Sorry, I've got a question. For instance, in signature, I will present that Friday. You can add arbitrary keys and value. Is that something you support with your system?
So right now, there needs to be a schema present for the data of the input, and that defines the fields of a JSON record, of a JSON object. Is that what you mean?
Yeah, yes.
And we actually for Zeek, what we do is we parse the header of the Zeek log data, which contains the schema, so it's completely dynamic. Unless we know, then don't know. For JSON, it's actually pretty easy to infer the type based on the field names. But since JSON type system is rather limited, we don't know the exact data inside the values. We have some inference. If it parses as an IP address, we actually use it as an IP address. So we try to infer the maximum typing already. In principle, it should be able to also support changing schema over time. It's just that when you run a query over a field that didn't exist in the past, you will only be able to restrict it to the schema that matches. But that's because it's such a rich type system and schema language, you can actually do a lot of tricks. For example, by tracking the lineage of the evolution, and then translate a query that goes over the field foo, for example, that used to be called in the bar in the past, and then translate that query automatically, and so that matches also over the past data. So that's That's also something we are very aware of, that fields constantly change, and we've seen that with Suricata, even within a version it changes frequently. So it's a known problem, and I think we are set up in the right way for it.
Okay, thank you.